Okay, so, oops, I am going to do your review. So if you see it on the review sheet, you will probably see it, not probably, you will see it on your test. So just make sure you go through everything here. And I'll try to be as detailed as I can. Oh, come on. Sorry. Oh my God. Here we go. 7 to the 4. So you want it in standard notation. Just that, all that means is, hey, write it in a number a day, that we use every day. Not exponential form, standard form. So take your calculator, and you will have a calculator, which I have to find, and I just did. So 7 to the 4th power, just put in your calculator, and it's 7 times 7 times 7, 4 times, right? So 7 times 7 times 7. You can either do that, or just plug in 7 to the 4th power, and you get this. 2 to the 9th, same thing. I'm not going to write 2 times 2 9 times, so just plug it in, and you get 500. Well, I'll do it. 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's what 2 to the 9th means, right? So that is 512. Careful with the next one. It's negative 5. Remember, the 4 is telling everybody inside the parentheses, multiply by yourself 4 times. So it's negative 5 times negative 5 times negative 5, and you get positive number, because it's negative times a negative. These two become positive, and these two become positive. So eventually your answer becomes 625. So just make sure that when you enter that in your calculator, you enter it with parentheses, okay? Because in the following example, you'll see why that matters. 3 to the 2nd power. So the 2 is telling this guy here, the 3, multiply 3 times 3 twice, and you get 9. Now, notice the difference between this one and the second one. So the 2 is saying raise of 3. So the negative sign is going to negate whatever it's being raised to the 2nd power. So put that negative side to the side, and then do 3 to the 3rd. 3 times 3, or 3 to the 2nd power. So again, negative sign hangs around, waits for you to do 3 times 3, and the answer is negative 9. Okay, because the 2, the exponent 2, has no power over the minus sign. It's just over the 3. Now, and again, compare that to the third one. Now, this third one, the 2 is saying everybody in the parentheses, raise yourself to the 2nd power, and that, in this case, includes the negative sign. So it's negative 3 times negative 3, which is positive 9. This is a negative exponent. Remember what we do with negative exponents? We write it as a fraction, right? And we write 3 to the 2nd power. The exponent becomes positive, and take it one more step. 3 to the 2nd power is 9. Okay. Now, this problem here and this problem here are very similar in the way you are going to deal with, this problem right here. So these two are very similar. So the negative, what's being raised to the negative 2nd power is just the 3. So let me put that minus sign towards the side there. And then do 3 to the negative 2nd power. And 3 to the negative 2nd power, I'm going to change it in blue, is 1 over 3 to the 2nd, right? That minus sign is still hanging out. So let me go back to red. And then we take care of the blue. And the blue is 1 over 9. Because 3 times 3 is 9. So be very, very, very careful. Okay, so if you put that in your calculator, let me just, actually I've never done it. 3 and raise it to the negative 2nd power. If you put that exactly as it is written in the calculator, it does give you negative 1 over 9. So just be careful. Make sure you put it in exactly as you see written. Okay. Rewrite the fractions below using the exponent. So we want to go backwards. 1 over 25 is the same thing as 1 over 5 to the 2nd power. Okay, and that's what it is written with exponents. 1 over 64, well, that has a couple of different answers. So you can either write it as 1, 8 to the 2nd, because 8 times 8 is 64, or 1 over 2 to the 6th power, because it's the same thing. So how will you know which one's correct? Well, if it's a multiple choice question, you either will see this one or this one. You won't see both of them together. So choice A might have been, I don't know, 1 over 8. Choice B might have been 1 over 8 to the second power. Choice C might have been 1 to the 2 to the third power. And obviously, in this case, we're only going to write one correct answer. So, but I'm just showing that there's two possibilities. Last one, 1 over 144. The same thing as 1. It's a perfect square. So notice that this is a perfect square, perfect square, perfect square. So what number do you know that raised to the second power is 144? That would be 12 to the second power. There is no other number for that one. Okay. 4 deals with, hey, what happens when you have a negative exponent? So how do we take care of that? Well, we learned that to change that negative exponent, we're going to write it over 1 and make it 12 over 12 to the second power, which is the same thing as 144. M to the negative 15, again, put it over 1, and the negative 15 becomes positive. And 4 to the negative third power is the same thing, put it over 1, right? And 4 to the third power, which is 64. 64 because 4 times 4 times 4 is 64. Next one, which ones are the same? Well, 1 over 16, there's not much to do, so let's leave it as it is. Let's figure out what's 2 to the 4th is. 2 to the 4th is 2 times 2 times 2 times 2, and that's 2, 4, 8, 16. So that's 16. So obviously 1 over 16 and 16 not the same. Let's do 2 to the negative second power. Let's write it as a fraction over 1. So 2 to the 4th. And 2 to the 4th is 2 times 2 times 2 times 2, 2, 4, 8, 16. Notice that this guy here and this guy here are the same, just written in a different manner. And then the last one is, again, remember, the 4 is not raising negative 2 4 times, right? Multiplying by itself 4 times, but it's just raising 2 to the 4th power. So that exponent there only has power over 2. So the minus sign hangs out there, and then we do 2 to the 4th, which is 2 times 2 times 2 times 2. Again, minus sign is there, and we evaluate 2 times 2 times 2 times 2, which is 2, 4, 8, 16, and the answer is negative 16. So the only two that are the same is 1 over 16 and 2 to the negative 4th power, because they're exactly the same. All right, now we get to apply all that. So the first thing I would do here, if I were you guys, is make the exponents positive. So a to the 5th stays, a to the negative 4th goes upstairs, right? B to the negative 16, negative 6 goes down, and B to the 12 is already positive, so it stays where it is. Don't leave your answer like that. We can combine, right? On the top, the bases are the same, so we keep the base, add the exponent, so you get a to the 9th, and at the bottom we get b to the 18th. So that's your final answer. Next one, let's do it in parts. 2 to the 4th, well, the 4 is positive exponent. There are no coefficients downstairs, no other number, so it's just 2 to the 4th. So 2, 4, 8, 16. So 2 to the 4th, we're going to rewrite that as 16. Let's do the m. M to the negative 5 goes down here. M to the 8th stays, because it's already positive. P to the negative 3 is negative, so it's going to go down. It becomes positive. P to the negative 9th power is positive, therefore it goes up. Not simplified yet, so 16, there's nothing else to do. Let's do the m's. The m's are being multiplied, so keep the base, add the exponent, so we get 13. And p to the 9 and p to the 3, that's the third power. That's a little bit different, so think about 9 p's being multiplied on the top and 3 p's being multiplied downstairs here in the denominator. If you simplify them, you're going to have 6 p's left over. Where? On the top. So this is my final answer. Next one, 5 to the negative 3rd power. Well, first of all, make it positive, so take it downstairs. K to the 0 is just 1, right? So I'm going to change that right 1. K to the negative 9 is it has a negative exponent, so it's going to go upstairs, so it becomes K to the 9. And M to the negative 3rd power is negative, so we can take it upstairs. It becomes positive. Let's simplify that a little bit. Well, 1 times K to the 9th times M to the 3rd is just K to the 9th. M to the 3rd, right? So we don't have to really write that 1, coefficient 1. And 5 to the 3rd power is 5 times 5 times 5, which is 125. But if you decide to write like this, no harm done. But we don't need it. Just go over your notes on the equations. No solution, one solution, infinite solution. So let's do the first one. Let's see which one it is. We have distributed property. No. Can I combine like terms? No. Are there variables on both sides? Yes. So get rid of the small one. We got to get rid of the 5m. So I'm going to do minus 5m here. Y in the middle and minus 5m here. That goes away. 10 comes down. 6m minus 5m is just 1m. Minus 20. Let me add 20 to this side and add 20 to that side. The 20 goes away, m comes down, and 10 plus 20 is 30. So there is only, this one is a one solution. Next one. Notice that the left side and the right side are very similar, but not quite yet. So distributed property, no. Combined like terms, no. Variables on both sides, yes. So let's get rid of the variables here. But they're both 7. Well, in that case, minus 7y here and minus 7y here. That goes away. I bring negative 12 down, equals, and then 7y minus 7y is 0. Notice that that is not a true statement. So negative 12 is never going to be equal to 0. So that tells you that this is a no solution problem. Okay. Next one. Distributed property, right? First thing you should do. So 6 times p is 6p. Positive 6 and positive 3 is 18. So we get 6p plus 18. On the right side, we already have 6p plus 18. And notice that these two expressions are exactly the same. So I can already know that it's going to be an infinite solution. So, and then just to go one extra step, I'm going to subtract 6p from this side, subtract 6p from this side, and we get 18 equals 18. So when you get to something like this, where the right side is equal to the left side, right, you know that this is going to be an infinite solution. So it doesn't matter what value at p that I put in here, right, I'm going to get the same answer on the left. A word problem. Silver Gym costs $80 to join and $30 per training session. World Fitness costs $140 to join and $15 per training session. Write and solve an equation to determine the number of sessions for the cost of both gyms to be the same. So when will they be equal to each other? So we're going to do that. So let's do silver over here. Silver, I gotta pay 80 bucks. Plus, every time I go there, I pay $30 per training session, for 30 times T. World Fitness is going to ask me for $140 up front, and then they're going to say, hey, every time you come, we charge you $15 per training session. When will these two be equal to each other? Well, let's go solve our equation. So 1, distributed property, no. 2, combine like terms, no, because I can't combine these two, and I can't combine these two. 3, are there variables on both sides? Yes. Which one's a smaller? This one's 30t and this one's 15t. So let's get rid of the 15t. Minus 15t, minus 15t. Line in the middle, sorry. That goes away because it's 0. 140 comes down. This is 80. Comes down because there's nothing to do. And then 30 minus 15 is positive 15t. Subtract 80 from this side. Subtract 80 from this side. The 80s go away because it's 0. 15t equals 60. We're going to divide by 15 and divide by 15. 15 divided by 15 is 1. And then we get t by itself. And 16 divided by 15 is 4. So in 4 training sessions, the cost of going to Silver Gym or the cost to go to the World Fitness Gym is going to be exactly the same. So most of your equation, most of your test is on exponents, but you'll have 2 equation problems. Okay, so just be aware of that. Bases are the same. We're multiplying. Keep the base. Add the exponents. 3 plus 7, and we get b to the 10th. Ta-da! Done. W9 over W negative 4. So let's make that positive first. So here, W9 stays where it is, but the W to the negative 4 is going to come upstairs. And it's going to be positive, and we get W to the 4th. Now we do the product rule. Bases are the same. Keep the base, add the exponents. We get W to the 13th. That's your answer. This is a power to a power, so make sure when you have an exponent outside the parentheses, you multiply that exponent times every power inside the parentheses. So let me write the 2 and the v first. So for the 2 is 2 to the third power, so 3 times 3, we get 9. And for the v, we're multiplying 6 and 3, we get 18. Final answer. Same thing here, but the first thing everyone should do is put a little 1 on top of the 4. And we're going to multiply -5 times 1, -5 times 4, and -5 times -3. So 4a and b. Let's multiply it first. -5 times 1 is -5. dA would be 4 times -5, which gives you -20. And the b will be -3 times -5, which is +15. Don't leave your answer like that, because our answer should have no negative exponents. 4 to the -5, let's take him downstairs. Exponent becomes positive. A to the -20, let's take him downstairs. 20 becomes positive. B to the 15 stays up. So, although that's completely fine with me, 4 to the 5th, it's something that we can do in the calculator. It's still not that big of a number. So B to the 15, there's nothing to do. 4 to the 5th, you might find your multiple choice written as 1024, and then A to the 20. So you either might find your answer multiple choice like that, or like that. So either of them, just look at your multiple choice. If it's not 4 to the 5th, just change it to a standard notation and look for 1024. More, it's again, more exponents. So let's do number 10. First thing I would do is change any negative exponents to positive exponents. So let me divide this. Let's do the coefficients first. That says 24 over 3. So if you think about 24 over 3, 24, and you put that in your calculator, you're going to get 8. Not 1 over 8. If it was 3 over 24, that becomes 1 over 8. If it's 24 over 3, it becomes 8. There's a big difference there. Okay, so in this case, it becomes just 8 in the numerator. That's taken care of. B to the -4 comes down. B to the 3rd was positive, so we don't move it. Take one more step. It's 8 over b to the 7th, because the bases are the same. We're multiplying, and we add the exponents. This one, it's multiplying. So first of all, multiply the coefficients. -12 times -4 is 48, positive. K to the 4th and k to the 6th, they're both positive. So if we keep the base, add the exponents, and we get that. Okay. Next one, again, take a look at the coefficients. So 9 over 27, if you had the fraction 9 over 27, you would get 1 over 3. D to the -5 comes down, becomes positive. E to the 6 stays up. Oops. Let me write 5 a little prettier. E to the 6 stays up. D to the 7 stays down because it's positive, and E to the -8 goes up because it was negative, now it's positive. Now, the E's, keep the base, add the exponents, we get 14. Do I need to write that 1 there? I don't, so I'm going to take it out. And then 3 at the bottom doesn't do anything, and then we have 2 D's being multiplied, keep the base, add the exponent, that's the final answer. Now, here, there's a reason why this question is here, because you'll see it. Remember I said, determine if the left side equals the right side. Well, let's see if it's exactly the same. So on the left side, we have 2 a's being multiplied. So we keep the base and we add the exponents. 9 times 12, 108. Here, we have a power to a power, so keep the base, multiply the exponents, right? So it's 6 times 6 is 36. Are they the same? No, they're not. There's a little line across. This one, 2 to the 4th times 2 to the 6, keep the base. Add the exponents. 4 times 4 plus 6 is 10, so that equals 2 to the 10th. Here, remember, when it's an exponent raised to another exponent, we multiply, so that gives me 24. And are they the same? No, they're not. Again, x to the 4th times x to the 11, keep the base, add the exponents, we get 15. And then it's a power to a power, so keep the base, multiply the exponents. 5 times 8 is 40. Are they the same? No, they're not. Okay, so just be very careful with that one. Here, like I said, first thing we all should do is put a little 1 here because we don't see on the exponent. There is. And that -5 multiplies every exponent inside the parentheses. Right? And sorry, don't forget that the m also has a 1. Right? So, let's do the 2. So it's -5 times 1, which is -5. The m's is -5 times 4, which is -20. The p's, is negative 3 times 5, which is positive 15. The 3 that's here in the denominator is negative 2 times negative 5, which is positive 10. The m is raised to the first power, so it's 1 times negative 5, which is negative 5. And the p, it's 2 times negative 5, which is negative 10. There's some movement that we have to do, change some of these to positive exponents. 2 to the negative fifth comes down. 3 to the 10th will stay. M to the negative 20 comes down. M to the negative 5th will come up. P to the 15 stays where it is. And P to the negative 10 goes up and becomes positive. Now I can do a little bit more simplifying. So 2 to the 5th, let's do 2 to the 5th times 3 to the 10th. They're not the same bases, so please don't keep the base, right? The bases are different. So 2 to the 5th is 32. Let me write 32. 3 to the 10th, so, and 3 to the 10th power is some ridiculous number, 59,049. So, should have used an easier number, but if you multiply those two, you know what, actually, I'm not even going to. I'm just going to leave it as it is. They're too big of numbers. Leave those two as they are. M5 and M20. Where are there more M's? Top or bottom? At the bottom. How many more? 15. P's, they're both side by side, which means they'll be multiplied. Keep the base, add the exponents. So that should have been your final answer. And if it's not, it means that they actually changed that to standard notation and multiplied, and you get some really big number. Okay. So that's done. Let's do this one again. Go ahead and put a 1 on top of the 4. Everybody else has an exponent, so we're good to multiply the 2 times that, this times 2, this times 2, this times 2, 6 times 2, and the exponent of 3 times 2. So let's write this down. 4, it's 2 times 1, which is 2. X would be negative 4 times 2, which is negative 8. Y, it's an exponent of 4 times the 2 outside, it's 8. The 8 would be 3 times 2, which is 6. The X would be 6 times 2, which is 12. And the Y would be negative 5, right? 2 times 2, which is negative 2. We can go ahead and do a little bit more, right? You're not going to find any of your multiple choice answers like that if it's a multiple choice question. 4 to the second power is 16. 8 to the 6th, I'll do that calculator, and you get, big number, 262,144. You could have just entered both, right? So if you entered this in your calculator, like that, and then ask it to simplify, it will probably simplify. So let's just do that. So in my calculator, I'm going to enter as a fraction 4 to the second power over 8 to the 6th power. Let's press enter. Oops, it's giving me a fraction. So I'm going to write 16 over 262, 144, and I'm going to press simp. Enter, domain error. Sorry. Try again. 16 over 262, 144. Simplify, enter. What the heck? 16 over 262, 16 over 262, 144. Enter. No, simplify. Son of a gun. Try again. 16 over, what am I doing wrong? 144. Simplify. It's giving me domain error. I don't know why. 16 over 262, 144. Simp. No. Delete. 262, 144, 262 divided by, oh my god, 262, 144 divided by 16. So, if you simplify that, okay, you should get simplified 1 over 16,384. That's what simplified would get you. Now, the rest of the fraction. So that 1, eventually we're not going to need it. X to the negative 8 comes down. X to the 12 stays as it is. Y to the 8 stays where it is. But Y to the negative 10 goes upstairs and becomes positive. Let's simplify this a little bit. y to the 8th and y to the 10th becomes y to the 18th. That 1 I'm not going to write. The denominator is going to be 16,384. That's going to be the coefficient. And then x8 times x12 is just x to the 20. And that should have been your final answer. Just give me a second. I want to know why I'm not able to simplify. 16 over, I'm just trying that, 8 over 20. No, that's simple. Okay. 16 over 8 to the 3rd. Oh, that's, well, 8 to the 6th, sorry. 16 over 8 raised to the 6th power. Press simp. I get the main, I don't know why I get the meaning. Alright, anyways, if you run into a problem simplifying, just let me know. 13. Oh, I need a bonus word. The bonus word is going to be, That's a good question. Let me just take a look here. I need to get your bonus word. Alright, so this is going to be your bonus word. Empire of the Summer Moon. Okay, it's the title of a book I read a while ago. That's your bonus. Next one, Bill weighs 120 pounds and is gaining 10 pounds each month. Phil weighs 150 pounds, gaining 4 pounds each month. Write and solve an equation to determine the number of months it will take for both of them to weigh the same. All right, so let's talk about Bill. Bill up here. Bill is currently at 20 pounds, 120 pounds, plus 10 pounds per month. And then Phil, a little heavier, 150 pounds, plus he's gaining 4 pounds a month. When will these two boys weigh the same? All right. Distributed property, no. Combined like terms, no. Is there variables on both sides? Yeah. So let's take care of the small coefficient. Minus 4m, minus 4m. That goes away. 120 comes down. 10 minus 4 is 6 equals 150. We do minus 120, minus 120 on both sides. That goes away. 6m comes down. And then 150 minus 120 is 30. Divide that by 6, divide that by 6. This goes away, becomes 1, and 1 times m is just m, and 30 divided by 6 is 5. So in 5 months, both gentlemen will weigh the same amount. Okay, so. And, this 14 relates to 11. So in 11, when we did 11, we noticed that none of them matched, right? None of them are equal. So, think about this. This is, let me rewrite it, t to the 4th times t to the something power is the same thing as this guy here, t to the 5th raised to the 8th power. Well, if you think about it, let me just move this upstairs. Let's do the right side because I have both values. T to the 5th raised to the 8th power. Well, it's a power to a power, so we keep the base and we multiply the exponents, and it gives me 40. So, over here it says t to the 4th times t to the something. What do I need to put over here so that it gives me 40? Well, notice that this one, when we're multiplying, right? We keep the base and we add the exponent. So 4 plus what number will give me 40? So it should be 36. So I put a 36 over here, right? Look what happens. On the left side, I keep the base, because we're going to use the product rule. Keep the base, which is t, and then I add 4 plus 36, which is 40. And that will equal the right side, which is also t to the 40. So the missing number over here, the missing exponent, is 36, right? On the right side, again, it says b to the 6 raised to what power over here would give me the same thing that I have on the other side. Well, on the other side, let's see what we have. We have a b to the 12 times b to the 9. So keep the base, add the exponents. 12 times 9, sorry, 12 plus 9 is 21. And in this case, I made a mistake because there's nothing that you can multiply that by to get you 21, right? 6 times what power will get you that? It's not going to happen. Okay, so please ignore this one. Don't ignore. I made an incorrect problem. Okay, so ignore that one. And that's it. Apart from that, you notice that it's very straightforward. No tricks, no anything. It's just you being very proficient with the product rule, the power rule, the quotient rule, right, and a couple of equation problems. And like a question like this, knowing that you have to multiply the outside exponent times every exponent inside the parentheses. Make sure you put a 1 on top of the 2. On this problem here, the first thing we should all start with is right off the bat, put a little 1 over here, or put a 1 on top of every variable or coefficient that doesn't have an exponent. So in this case, it was just a 4. Here, this problem, right? Just be careful, the m didn't have a visible exponent, but let's go ahead and put the 1 so that we know that the negative 5 multiplies to 2, negative 5 multiplies to 1, negative 5 multiplies negative 2, and so forth. Okay, so that's it for your review.